Ladies and gentlemen, welcome to another episode of the Nerd Chronicles. This is your host, proud lame certified beta male simp with no game whatsoever. The socially awkward nerd Christian Paul has just entered the scene. Basically, I know we are actually trying to warm up for hair model auditioning for folks that want to emulate the Herbal Essence moment or Fabio moment today. While before we even try to do that at this time, I want to get you guys involved with cluster analysis, right? Or clustering for short, which is basically solving a problem that's unsupervised, a computation that's unsupervised, however it may be. Basically, in other words, it is a strategy with no strategy, e.g. the project we will be doing within the weeks to come, right? When it comes to shopping for hair products, shampoos, conditioners, blowout tools, hair tools that, a lot of consumers mainly do, and 85% of those consumers, according to Forbes statistics, are women. Not just when it comes to the beauty industry or the toiletry industry, but virtually like with all consumer goods. Shockingly enough, from what I found, right? So especially when you see a lot of women purchase things from like the beauty industry, it's a whole strategy, strategy based on what type of products that they mainly use to try and make themselves feel like a supermodel that day. So, cluster analysis, right? Often used as a data analysis technique for discovering innocent patterns in data. Mathematics is groups of customers that are based on their behavior, i.e. women picking a certain product for their hair or certain tools for their hair to try and emulate the models that they see in hair commercials, right? So they don't have to be feeling too bummed out or stressed or deeply insecure. So, we know that there are many clustering algorithms to choose from, and there's no one best clustering algorithm for all cases, as every case is different. But it is always best to experiment a range of clustering algorithms and different configurations for each problem that is shown, right? And they have some clustering algorithms that you see down below, which they talk about library installation, clustering data sets, affinity propagation, algorithm clustering, BERTs, DB scan, k-means, mini-batch k-means, mean shift, object spectral clustering, and Gaussian mixture models, right? So they got all these acronyms they have below, and we know that clustering is unsupervised and mainly involves discovering natural grouping in data. Unlike supervised learning, in which you have predictive modeling, clustering algorithms only interpret the input data and find natural groups or clusters in the feature space, right? And the clusters often the area density in the feature space where examples from the domain are closer to the cluster than other clusters. The cluster may have had a center or centroid, that's the sample, or a point feature space. It may have a boundary or extent limit, in other words, right? Clustering can be helpful as a data analysis in order to learn more about the problem domain. So, call pattern discovery or knowledge discovery, right? Basically the predictors, right? And they got a bunch of examples here. And we know that clustering can also be used for some type of feature engineering where existing new examples can be mapped and labeled as belonging to one of the identified clusters in the data. Where the evaluation of the identified cluster is subjective and may require a domain expert. Although many clustering specific quantitative measures do exist, typically clustering algorithms are compared academically on synthetic data sets for predefined clusters, which an algorithm is expected to discover. Right, and now we have a bunch of clustering algorithms as we have discussed below. And those algorithms, many of them, use similarity or distance measures between examples in the feature space in an effort to discover dense regions of observations. As such, it's often good practice to scale per data prior to using clustering algorithms. Some of those algorithms require you to specify or guess at the number of clusters to discovering the data, whereas others require the specification of some minimum distance between observations in which examples may be considered close or connected. As such, cluster analysis is an iterative process where subjective evaluation of the identified clusters is fed back and it changes to algorithm configuration until a desired or appropriate result is achieved, right? And we are actually looking to the Python version when it comes to scikit-learn of these clustering models below, in which each of these algorithms are mainly different, which is not really a best one. Every one is basically different depending on the scenario. For example, with the whole beauty industry scenario as well, way too unpredictable, right? So let's dig into the examples here, right? In order for you to start, you would have to use a make classification function in order to generate the range and to basically create a random generator. Alright, so we have a bunch of examples on how you basically deal with clustering as well, right? And you make those classifications when it comes to propagations, and you basically would predict some of the stuff that is actually shown below, right? So many options in so little time. Now, I'm not going to go through this whole page. For more information on this site, please check out Dr. Jason Brownlee on machinelearningmastery.com/clustering algorithms for Python. The information will literally be down below. And if you want more thorough information based on like the theoretical aspect of clustering, you can also look at Wikipedia as well. Christian Paul from the Nerd Chronicles signing out. Have yourself some happy urges. Yeah.
Jane, what are we doing tonight?
Sorry. Gotta wash my hair. Bye.
Sarah.
Sorry, Jake. Washing my hair.
Now that women have discovered Clairol's herbal essences, the all-natural botanicals, the organic herbs, drenched in pure mountain water.
Yes!
They've all got better things to do. Herbal essences, a totally organic experience.
Hi, Jakey. Bye, Jakey.
Juicy.